Okay, so for 11-3, area of circles and sectors, we first have to understand what the area of a circle is. So if you remember, circumference was 2 pi r. Circumference equals 2 pi r. That was just 2 times the radius. And we were allowed to use diameter for circumference because that's the same as just diameter times pi. But for area, it's pi r squared. So we have to have the radius. We cannot use the diameter here because squared is different than times 2. And so since our radius is squared, we'll have units squared. So if it was inches, you'll have inches squared. If you had miles, it'll be miles squared. Or square miles. That's how we read it, okay? So then that's how we do area. So that's just the simple thing, just like circumference, area. And then let's talk about sectors. So sectors are like a slice of pizza, okay? The shaded region right here. The way we name it, because that's half of geometry is naming things properly, is with the word sector and a point on the circle, A, the center, O, and another point on the sector, B. So we say sector AOB. Now for area of a sector, this is very, very similar to length of an arc, okay? So we take the measure of the arc, 50 degrees, over 360 times the area. We did the same thing when we were doing length of an arc. We did measure of the arc over 360 times circumference because we wanted to know what fraction of the circumference it was. Now we want to know what fraction of the area this is. So I take this, measure of arc AB is 50 over 360 times area. And for area, we have to take pi r squared. My radius is 3, so 3 squared is 9. We're always going to leave in terms of pi unless the problem states to do otherwise. And I have 9 pi inches squared. Remember, units get squared when we are using area. So now I have 50 over 360 times 9 pi. I can either multiply this first, or what I really like to do, I like to reduce 50 over 60 to, zeros cancel out, 5 over 36. So then I'll have 5 times 9, which is 45. That's times 9 pi, over 36. 45 pi over 36. We can reduce that, and by 9, divide the top by 9, divide the bottom by 9. And we get 5 pi over 4 inches squared. So that's what the area of sector AOB is. So there's not much more to it other than just make sure you use the shaded region, measure of arc over 360 times the area, okay? And use the radius to find the area. I believe that's only example problems. So the problems aren't that hard, but that is what 11-3 area of circles and sectors is all about.